The purpose of this exercise is to wrap our heads around why it feels harder to ride a bike in some gears than in others. In doing so, we are going to find the distance traveled for every rotation of the pedals, the gear ratio, and the mechanical advantage. Besides illuminating the relative difficulty of different gears, these values can help us design a bike that is optimized for speed or ease of riding. To start, we need to open the full model of the bike. If you have not already done so, you can download the model from the Digital Steam website. Once we have the model open, we need to make sure the chain drive is set to flexible. This will allow us to drive the back wheel by moving the pedals. Now try moving the back wheel by turning the pedal. What do you notice? Try counting the number of rotations that the wheel makes for every rotation of the pedal. How many times does the back wheel turn? Would it be harder or easier if the back wheel turned a greater number of times per rotation of the pedal? Let's compare these rotations to the gear ratio, that is, the ratio of teeth on the front sprocket divided by the teeth on the back sprocket. We can quickly calculate the gear ratio by counting the teeth on the sprocket, or we can save ourselves some hassle, right-click on the chain drive and select Edit using the Design Accelerator. Then we just divide the number of teeth on our front sprocket by our back sprocket, and the result is our gear ratio. To measure the precise number of rotations, on the other hand, we need to count the revolutions and then measure the remaining angle. If we click on the View tab and click Object Visibility, this will let us see conveniently located planes that we will use to measure the rotation of the wheel. Then we unsuppress the rotation lock mate and the reset wheel angle mate. This will give us a clean start to measure the angles from. To actually turn the wheel, you must once again suppress both of these mates and turn the pedal one full rotation. Record how many times the wheels rotate. Then we once again unsuppress the rotation lock, and we have rotated the pedal exactly one turn. Now we measure the final angle of the wheel. Click the Inspect tab from the drop-down menu and click Measure Angle. This will give us the angle between the wheel and the start point. Unfortunately, it's not the angle in the direction we were rotating, so we'll need to take the conjugate of this angle. Record the angle and then subtract it from 360. Write the number down on your worksheet. The reason the ratio of the pedal rotations to the back wheel rotations is the same as the gear ratio is the pedal is rigidly attached to the front sprocket and the back wheel is rigidly attached to the back sprocket, but the two sprockets are attached by a chain. The chain engages with the teeth of both the sprockets such that every tooth on the front sprocket matches up with one tooth on the rear sprocket. The catch is, there are more teeth on the front sprocket than there are on the back sprocket. Okay, let's do the whole thing again using a different gear ratio. You can change the ratio by again opening the Design Accelerator and double-clicking the lower gear, then changing the number of teeth from 17 to 27. If we repeat all of the steps from before, we can again find the number of rotations on the back wheel by counting them and measuring the final angle. Record the angle on your worksheet to use in calculating the exact number of rotations later. This is interesting, but what does this mean while you're riding a bike? I want to know how far a bike will travel per rotation of the pedals in each of the gear ratios. If the wheel is not slipping, every point must touch the ground. This means that for every rotation of the bike wheel, the wheel must travel a length equal to its circumference. To find the circumference, open the rear wheel assembly and then open the tire part. Right-click on the Revolution 2 in the feature tree and select Edit Sketch. Then you can measure the diameter and calculate the circumference. In case you forgot, it's 2 pi r, or pi times the diameter. If we multiply the circumference by the gear ratio, we get the distance traveled. We can also get the radius of the pedals by measuring the crankshaft. Return to the main assembly and right-click on the crank drive side, then use the Measure tool to measure from the pedal bearing holes to the drive shaft hole. The ratio of the rear wheel radius to the radius of the crankshaft is the gain ratio. The inverse of the gain ratio is the mechanical advantage. In this case, we actually have a mechanical disadvantage, which means we are pushing harder but traveling faster, that is to say, further per rotation of the pedals. How does this compare in the second gear ratio? How does this compare to your own experience?